Hey guys, hope you're well. If you want to download the paper, check the description below the video. They give us a bunch of numbers here. They say that x can be either the numbers 0, 1, 2, 3, or 4. Write down a value of x so that this expression is undefined. Undefined, I want you to hear the word under, and so I want you to look underneath the fraction line, which is over there. Now, when something is undefined, it means that this part at the bottom, the part underneath, is equal to 0. That doesn't mean the answer is 0 here. It means we want all of that to be equal to 0. So we want that part to be equal to 0. So if you had to look at this and you had to solve for x, you should eventually see that x will be equal to 4. So that would be that one. So we can just say 4 over there. Now, rational. For this to be rational, rational would be, think of it as a nice number. You want to get something nice. So for example, if I go put, you want to get like any fraction, that's also a nice number. So for example, if we go let x equal to 0, let's see what we get. 9 over 4 take away 0. If you type that on the calculator, it's going to give you 3 over 2. That is a nice number. That is a nice fraction. And so we can actually just choose 0. If you had to go choose 1, you would end up getting something that isn't that nice. It would have a whole bunch of decimals. If you chose a 2, it would have a whole bunch of decimals. If you chose a 3, it would also be really, really nice. And so you could also choose 3. So you could choose 0 or 3. And then if you chose 4, that wouldn't work. So let's just say 0 or 3. Okay, but you only have to choose one of them. Now, irrational. Well, irrational is when you get decimals that don't stop or don't don't repeat. It's like 5,13618,246,113. It just doesn't stop and it doesn't repeat. Repeat is when it's like 5.13131313. If it repeats like that, that is rational. But if it doesn't repeat, then it's irrational. So you can go ahead and go plug in a whole bunch of these values. But what you would find, if you plug in 0, it would be rational, like we said. So that's not going to work. 3 is also not going to work because we already looked at that one. And if it's a 4, then we said that's undefined. So the only two other options would be 1 and 2. So you could say here 1 or 2. Simplify the following. Okay, so a lot of learners, they make mistakes in a number of ways here. One of them is that they try to take this and they try to multiply it in here. Why can't you do that? The reason is that you've got a 2 over here, so you cannot do it that way. Okay. Another thing some learners do wrong is they take this 2 and they just say, oh, I'm just going to put it there and I'm just going to put it there. That is also not correct. If it was like this, where you've just got one term over here, then you can take the 2 and put it to each of those places. But when there's more than one term, because we can see there's a minus here, so there's 2 terms, then what we're rather going to do is make double brackets. So we're going to go b minus 5c and then b minus 5c. So here we now have 3 things that we are multiplying. 1, 2, 3. You are allowed to multiply any 2 of them together, and then that answer, we will multiply it with the third one. So what I like to always do is I like to leave this one alone, and then I like to go and multiply these 2 together. So we end up with, now remember, here's where we're going to use FOIL. So that means the first one in the first bracket and the first one in the second bracket. We're going to multiply those 2 together. That'll give you b squared. Now we move on to O. O means outside. So it's the outside one of this bracket and the outside one of that bracket. So if you multiply those 2 things together, that would give you negative 5bc. The next part is I. That stands for inside. So it's the inside of this one and the inside. What do we mean by inside? So let me explain that a bit better. It's these 2 over here. You see they are on the inside, whereas these other 2 are on the outside. Okay, so it's the minus 5c and the b. That would give you minus 5bc. If you say bc or cb, doesn't really matter. Same thing. And then the last one is L, which means last. It's the last one in this bracket and the last one in this bracket. So that'll actually end up giving you a positive, because a negative times a negative is a positive, and a c times a c is a c squared. Now, can you see that these two go together because they are like terms? So let's go put them together. You can just do this on your calculator. What is minus 5 minus 5? Well, that'll be minus 10. Okay, now we can multiply this last part in. Should put equal signs here. And so we're just going to multiply there, there, and there. Okay, so when we multiply this first one, it's going to be 2b cubed. Then we're going to multiply it into there. It'll be minus 20b squared c. Then we're going to multiply there. It'll be 50bc squared. And there's your answer. With this question, there is a mistake. This x is in the wrong place. It is supposed to be up here. Okay, so for some of you, I do apologize if you're following this in the exam paper and you realize that there's a mistake over there. Okay, so let's just rewrite it. Now, if you've watched my videos on these types of questions before, you would know what we need to do. First of all, that is not 2.3. That means 2 multiplied by 3, but you can't turn it into a 6 because this 3 also has exponents. So these are one of those questions where we're going to first go ahead and break this up as 3 to the x, 3 to the minus 1. And then at the bottom, I'm going to do the same. So it's 3 to the x, 3 to the 2. So I just broke that up over there. And then 3 to the x and 3 to the 1. So I just broke that one up there. The next step we can do is we can take out a common factor. Can you see there's a common factor of 3x in both terms at the top? So we're going to take that out. What we're going to be left with is 1. Because when you take a 3x out of here, you're just going to be left with 1. And then what are we left with over here? Well, we still have a 2 and a 3 to the minus 1. Okay. At the bottom, we're going to also take out a common factor of 3 to the x. And then we're just going to be left with 3 to the 2 plus 2 times 3. Okay, the reason we did that is so that these can cancel. And so now we're literally just left with a number. You can go type this on your calculator. If you type that on the calculator, you should end up with 1 over 3. And then you can go type this on your calculator. That should give you 15. And then you can go type that on your calculator. And that will give you 1 over 45. This question wants us to factorize. So there are 5 kinds of factorizing. The first one I always look at is a common factor. Then I would look at difference of 2 squares. Then I would look at trinomial. Then I would look at grouping. Then I would look at difference of cubes. Difference of cubes. All right, so this one looks like it's going to be a grouping one, but also mixed with a common factor. So I'm going to group these two together, okay? And then I would also group these two together, and I'm going to group those two together. But it gets a little bit weird with the negative over here. But let's just see how it goes. So what is the common factor over there? The common factor there is a. So then I'll be left with a minus x. Okay, so it looks like this is not actually going to work, because if I look in this next part, there's not going to be an a and x. So that actually doesn't work. So there's got to be a better way we can do this. I'm then going to try go with, okay, I'm going to put these two together, and then I'm going to put these two together. Let's try that. So that's going to be a squared minus 1 minus ax plus x. So now I know that this over here is a difference of 2 squares, because I know that there's 2 terms separated with a minus, and I know that this is a perfect square because it's a times a, and this is a perfect square because it's 1 times 1. So then I can open up 2 brackets, a minus 1, a plus 1. That's just difference of squares, right, which we've done. Then for this part here, I'm going to take out x as a common factor. And so if you take out x, then you'd be left with a over here, and you'd be left with minus 1. Let me explain where I got minus 1, or let me also explain how I got a. So because I took an x out of this, it gets a little complicated with the negatives. So I took out a negative x. Now, if I had to multiply these two together again, what would that give me? Negative ax, and that is exactly what we had. And if I had to multiply these two together, what would that give me? positive x, and that is exactly what we had. So as long as this step actually still gives you that, then you've done it correct. But if you went and put a plus over here, that wouldn't work, because now that would give you minus x, but over here it was plus x, and so that's why I did that. Okay? Now, I know that we've now done everything correct, because now I can see that we've got a common bracket, and that's how we're going to get our third mark, by going to the next step. We can now take out a common bracket of a minus 1, and what would we be left with? Well, in the first term, we would still be left with a plus 1, this one over here, minus, and then in the second term, we're still going to be left with this x. And that is our final answer. I still have grade 12 learners that would get this question wrong, but it's so easy. But what some grade 12 learners do, and grade 10s and 11s do it as well, is they think that they can divide by x on both sides. You cannot do that. When you have a situation like this, take everything to the one side, make it equal to 0, and then factorize. I would be super rich if I earned 1 rand every time students did that mistake. So with factorizing, we know that there are 5 types. We can take out a common factor. We can do difference of 2 squares. We can do trinomial. We can do grouping. And we can do difference of cubes. So here we're just going to start with a common factor. We can take out x as a common factor, and then you're left with 3x take away 2. Now, when you have this step, you can just say this part equals to 0, or this part equals to 0. And now this one, we can still go a little bit further and actually solve it. So I would take the 2 to the other side. And then to get x alone, we have to divide by 3. But what we do to the one side, we have to also do to the other side. And so there we go. So the 2 answers are that. The first thing I notice in this question is that we have fractions, and so we're going to have to get common denominators. But before you get a common denominator, make sure all of the denominators are factorized, okay? Before getting a common denominator, make sure all denominators are factorized. Okay. So I can't factorize this, I can't factorize this, but I can definitely factorize that. Can you see that that is a difference of 2 squares? Because we've got 2 terms separated with a minus, and I know that this is a perfect square. I know that it's x times x, and I know this is a perfect square. It's 3 times 3, and so I can then say 2 brackets, and I put x and x, 3 and 3, and then one of them gets a plus, one of them gets a minus. It doesn't matter if you switch the order around, that doesn't matter. Okay, now the reason we've done that is to realize that all 3 of these are now very, very similar. This one and this one are exact. These 2 are almost the same, so let me show you a trick to make them the same. All you do is, for example, you just take this one, and all you're going to do, guys, look at this. You're going to change the sign in the front over here. At the moment, there's nothing there, so it is positive. You're just going to make it negative. And then you're going to switch this one so that the 3 becomes negative and the x becomes a positive. So let me explain that again. You're going to change the sign in the front, so it is currently a positive. You're going to make it a negative, and then you change the sign of both of these. This 3 was positive. Now we're going to make it negative. And this x was negative, now we're going to make it positive. Now, did you know that this is actually exactly the same as this? Let me explain. When we are adding, the order doesn't matter. You're allowed to switch order. For example, 3 plus 4 is the same as 4 plus 3. So when you are adding, order doesn't matter at all. So I can now rewrite it as positive x in the front and then negative 3. Okay. Now, everything's amazing because check. Now we've got x minus 3 there, and we've got x minus 3 there. We've got x plus 3 there and x plus 3 there. So our lowest common denominator is just going to be x plus 3, x minus 3. Because all I need to do then is I just need to multiply this one over here by x plus 3. What you do to the bottom, you do to the top. All I need to do is multiply this one by x minus 3. What you do to the bottom, you do to the top. And I don't need to do anything with that. Now, can you see that all the denominators are exactly the same? And that is what we want. Because now we know that when you have an equation and all the denominators are the same, you can ignore the denominators. And so now all that we have is minus 7 equals to 5x plus 3 plus 4. That is it. We don't need the denominators anymore because they are the same. So all I need to do now is just multiply this minus 7 into this bracket, and I do the same with this 5, and then I just start simplifying. So this is going to be minus 7x, and then minus 7 multiplied by 3 would be minus 21. 5 multiplied by x, and then 5 multiplied by minus 2 will give you negative 15 plus 4. Now we're just going to take all the x's to the one side, all the numbers to the other side. You can do this however you want. So I'm going to take the 5x to the left, and I'm going to take this minus 21 over to the right. So on the left we would have minus 7x minus 5x, because obviously when this goes over it becomes a minus. And then we have minus 15 plus 4 plus 21, because when this goes over it becomes the opposite sign, so it becomes positive. You can put this in the calculator, but it should give you negative 12x. This would give us, let's go pop that on the calculator. Kevin's lazy today. 10. And so to get x alone, you would divide both sides by negative 12. And so x would be negative 5 over 6. With this question, if you're a student that was looking at this question from an exam paper, you would have noticed that there was like a weird comma here. That is not meant to be a comma. It is not 16 comma 2. It's 16 multiply by this expression over here. This one is a comma because it's 0, 5. So this over here is an exponential equation. So with an exponential equation, the goal is eventually to end up with something like this, where you've got these two numbers exactly the same. If you can get to that, then it's really easy, because then in the next step you just ignore the 3's and then you just say x minus 1 equals to 2x plus 4 as an example. So we have to somehow try get to that in this question. So what I would do is, I know that the number 16, if I type it on my calculator and I press equals and I press the shift button and then I press fact, I know that that is the same as 2 to the power of 4. And I know that 0, 5 is actually the same as a half. And I know that if I want to write this in a different way, I know that a half can be written as 2. I can bring the 2 to the top and then just put it as minus 1. You need to be familiar with the fact that these two are the same. Okay? So I'm going to actually change that then to 2 to the minus 1. Now, when I have something like a to the 3 multiplied by a to the 4, that becomes a7, because we know with exponent rules we must add these numbers. So here I've got these two as the same. So what do I do with these exponents? I add them. And that's going to then be 4 plus x minus 1. Some of you are like, Kevin, shouldn't we just multiply the 2 and the 2 to become 4? No, we cannot do that, because this 2 and this 2 has an exponent and this 2 has an exponent. So instead you have to use exponent rules like we have over here. Okay. And so even if you look at the rule, see what the rule says? If it's a over here and a over here, you keep it as a. So if it's 2 over here and 2 over here, you keep it as 2. You don't multiply them together. And then over here, we know that with exponent rules, we should multiply. So that's going to become negative x, because negative 1 multiplied by x is negative x. And then negative 1 multiplied by negative 4 actually becomes plus 4. Okay, now we are in business, because check, we've got a 2 on both sides, just like I showed over here. So you can ignore those 2's now. And all that we're left with now is 4 plus x minus 1 equals to minus x plus 4. And now it's just a normal equation that you can solve, where you take all the x's to the one side. So I'm going to take the x to the left, and then you take these numbers to the other side. And so on the left, we're going to have x plus x, because when I bring this one over, it becomes a positive. And then on the right hand side, we're going to have 4 minus 4 and then plus 1. And so on the left, we're going to have 2x, and on the right, we end up with 1. Then to get x alone, you divide both sides by 2, and so x is a half. Here we've been given an inequality. All that means is that we have this symbol over here. It could also go the other way. So all that we do is you're still going to treat it like a normal equation. You're going to get x alone. So you could take x that side, or you could keep it here. I'm going to keep this x over here, and I'm going to take this 2 over to the other side. So I'm going to end up with this on the left, and then the 2 is going to become a minus 2, because when you take it over, it changes sign, and that's going to give you 12. Now, there are multiple ways on how you could handle this. I'll show you a couple different ways. One of them is to get x alone, you need to divide by all of that. So you divide by negative 3 over 4, and what you do on the one side, you do on the other side. And then what you must remember, when we are busy with inequalities, if you ever have to divide by a negative number in order to get x by itself, this must change. So what you would then end up with on the left is x, because these are going to cancel. But then the sign has to change. And then this you can just type on your calculator. I think it's going to be 16. But let's just double check. 3 over 4. Yeah, 16. But it'll be negative 16. And so that would be your answer. However, if there are other ways you could have done that. So let's say, for example, we had this and this. What you could do is you could first take the 4 to the other side. So how would you do that? Well, you could multiply this side by 4. And what you do to the one side, you do to the other side. Why did I multiply? Well, because this one's at the bottom and now this one's at the top, so they cancel. So then you would end up with minus 3x is smaller than 48. Then in your next step, you would have to divide, let me just write it over here. In your next step, you would have to divide by minus 3. And what you do to the one side, you do to the other side. Now that we're dividing with a negative, remember you have to flip the sign. And so you would end up with x, and then it would face that way, negative 16. Same answer, of course. So the answer is x is bigger than negative 16. Now it says, write down the first natural number. What are natural numbers? Natural numbers, if we look on a number line, at 0, 1, 2, 3, natural numbers start at 1, okay? And they go on and on and on like that. So it's the numbers 1, 2, 3, 4, 5, 6, 7, fast forward, Kevin's counting, 1,632,342, 1,600,000, okay, you get the idea, right? It counts that way. So it says, write down the first natural number that will satisfy this inequality. So it says that x can be any number bigger than minus 16. So if minus 16 is over here, well, it would be a lot further, but you get the idea. It would be like over here. And then you'd get minus 15, 14, 13, dot, 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 minus 2, minus 1. So x can be any number bigger than minus 16. That means x can be any number to the right of that. So minus 15, minus 14, minus 13, all of those are bigger than minus 16. Wait, Kevin, how is minus 15 bigger than minus 16? Isn't 15 smaller than 16? Yes, but when you're looking at negatives, it works the opposite way. Minus 15 is actually bigger than minus 16. And so they said, yeah, write down the first natural number that'll satisfy. So the first natural number is going to be the number 1, because as we keep going, the first natural number we're going to reach is 1. Here we have to solve simultaneously. Now, in grade 10, we have 2 ways of solving simultaneously. I will show you both. So the first one is my favorite, which is called substitution. The reason it's my favorite is you only use that in grade 11 and 12. But in grade 10, you can still use elimination if you want, whatever you feel comfortable with. You could even use elimination in grade 11 and 12, but we use substitution a lot. Okay, so how does substitution work? Well, what you do is you look at this equation. So we'll call this number 1, we'll call this number 2, and you got to try get x or y alone in one of them. So I can see that there's a y over here. So I'm going to take that equation, and I'm going to get the y alone by taking the 2x to the other side. So it becomes negative, because over here it's positive. And when you go over the equal sign, you'll change the sign. I'm now going to call that equation 3. I'm then going to substitute, hence we call it the substitution method. Yep. we're going to substitute that new equation into the equation over here that we haven't yet used. We haven't yet used number 2. Okay, so what does it mean to substitute? It means to replace. Okay, so you're going to replace. So we're going to replace this. So we're going to replace y with 8 minus 2x, because you see how they are equal. So wherever I see a y over here, I'm going to put a bracket. Okay, so you see how I've just taken this equation, and when I saw a y, I put a bracket, and then I'm going to replace the y with 8 minus 2x. Okay, that's all you do. And now you're just going to go and solve. So you're going to multiply the 2 in, so that's going to give us 16 take away 4x. Okay, you can solve this however you want, but I'm going to take the 16 over to the right, so it's going to end up becoming negative 16. And now what is minus 4 plus 3? Well, that's going to give you minus 1, so minus 1x, and on the right you're going to end up with minus 18. Then to get x alone, you divide both sides by minus 1, and you should end up with x equals to 18. That is not the final answer. You also have to go and find y. So what you then do is you come back to equation number 3, because y is equal to 8 minus 2x, and we already found x as 18, which we just found over here. And so you would then end up with 8 minus that. Why did I just write the same thing twice? And so if you go type that on the calculator, that's what I was meant to say, you end up with negative 28. So x is 18, y is minus 28. If you're happy with that method, you don't need to watch this method. But for those of you that like elimination, let me show you how to do it. You put the x's on top of the x's, you put the y's on top of the y's, and you put the numbers on top of the numbers. So this would be like that. So you see how I switched this around, okay? Now, we either want to try and make these two exactly the same, or these two exactly the same. I'm going to try and make these two the same. How could I do that? I could multiply this equation by 2. So I could multiply this whole equation by 2. And so what we would end up with, so we're going to multiply by 2 over here and by 2 over here. And so we're going to end up with 4x for this part plus 2y, because I just multiplied by 2, and then 8 times 2 is 16. Now that these two are the same, I can minus these two equations. So you could either say this one minus this one, or you could say this one minus this one. It doesn't really matter. So if I call this equation 2 and this equation 1, I'm going to take equation 2 minus equation 1. So what is 4x minus 3x? Well, that'll just give you x. And what is 2y minus 2y? 0. And what is 16? Be careful now. What is 16 minus minus 2? So it actually becomes 16 plus 2, because it's 16 minus, and then there's also a minus. So 2 minuses make a positive. So you end up saying 16 plus 2. And so x is 18, just like we got over there. How do we find y? To find y, you can just go plug the x that we just found into any of these equations. You can plug it into this original equation over here. You could plug it into this one over here. You could plug it into this new one. It doesn't matter. I'm just going to go plug it into here. So 2 times x plus y is equal to 8. And so 36 plus y is equal to 8. I'm going to take the 36 over to the other side, so it becomes negative. And then I get negative 28 for y. So you get the exact same answers, of course, just 2 different methods. Consider the functions f and g. F and g intersect at points A and B. Okay, right, so this is going to be a parabola because it's got that. And this is going to be a straight line. So it says calculate the values of A and C. All right. So what we can do, we don't even have a graph to look at. So we're going to just go take this point, and we're just going to go plug it in here. What you must understand is that, why am I plugging it here and not here? Well, they want us to find A and C. So I'm going to take this point. You must remember this is a x, this is a y. So I'm going to go plug in the y over here as minus 3. The x is minus 1. I'm definitely going to put it in a bracket like that. And I'm just going to simplify a little bit. If you type this on your calculator, it just gives you 1. Now what is a multiplied by 1? It's just a, so I can just write it like that. Perfect. There's nothing more you can do there because we've got two unknowns. So all I do next is I just go do the exact same process using the 2 and the 0. So once again, this is a x, this is a y. So I'm going to go plug the 0 over here, and then x is 2, and so this becomes 4, so it's 4a plus c. Now we have two equations with two unknown, and so we can use simultaneous equations. Now remember, with simultaneous equations you can use elimination, you can use substitution, whatever you want to do. Okay, I like substitution. So this is my first equation, and then this is my second equation. So I'm going to take this equation over here, and I'm going to get, actually I'm going to take this equation and I'm going to get c by itself. So the way I'll do that is I'll just take this to the other side, so it'll become negative. And there we go. That is going to be equation number 3 now. So I'm going to substitute number 3 into the equation that I haven't used, which is number 1. And so what that means is, can you see from this equation here, it says that c is minus 4a. So I can take this equation now, and when I see a c, I can replace it with minus 4a. Why? Because c is the same as minus 4a. So instead of writing it as a c, I can write it as a minus 4a. But why would I want to do that? The reason is that now I only have a's. Can you see? Whereas over here, I have a and c. Over here, I have a and c. I don't want to have two letters in my equation. I only want one. Because if there's two, I can't solve it. But now I can solve it because there's only one letter. So this plus and this minus next to each other just becomes a minus. And then minus 3 will become, what is 1a take away 4a? You can even say on your calculator 1 minus 3. That'll give you negative 3. Now to get a by itself, I have to divide both sides by minus 3, because what you do to the one side, you do to the other side. And so a will end up being 1. Okay, so we have a, perfect. Now we need c. So to find c, we come back to this equation over here, and it says that c is equal to minus 4a, but we now know that a is 1. We just calculated that. So that means c would be minus 4. So a is 1, c is minus 4. This one says calculate the values of b and q. Okay, so the exact same thing. Let's just quickly see f and g. Yeah, we can do the same thing. I'm just trying to think if there are other ways we could do it. No, let's just go do the same thing. There's always multiple options, but this is one of them. So once again, we're just going to go plug in values. So I'm going to start with this one over here. Remember, that is a x, that is a y. And so that goes in the place of y. Minus 1 goes in the place of x, and then plus q. And so that's going to give minus 3 equals to negative b plus q. Just remember that. That's not a 6, that's a b. Now we're going to take this point over here and do the same thing. So that's x, that's y. And so we're going to plug in 0 over here. And we're going to plug in 2 in the place of x. And so we end up with 0 is equal to 2b plus q. And now once again we have a simultaneous kind of equation. So I'll call this number 1, I'll call this number 2. Your goal now is you can either use elimination or substitution. I'm going to use substitution. I'm going to start with this equation here, because remember, with substitution you want to get either a b or a q by itself. There's multiple options here, but I'm going to just choose this one, and I'm going to take the b to the other side like that. And I'm going to call this equation number 3 now. So now I'm going to substitute number 3 into number 1. Remember, we haven't used this equation. So remember, it says here that q is minus 2b. So wherever I see a q, I'm going to replace it with minus 2b, because q is minus 2b. And so now we end up with a positive and a negative next to each other, so that becomes a negative. And so we end up with negative 3 equals to negative 3b. And then to get b alone, you divide by minus 3, and what you do on the one side, you do on the other side. So b is 1. To find q, I then come back here, because it tells me over there that q is minus 2b. So q is minus 2 times the b value, which is now 1. And so q is minus 2. So we found b as 1 and q as minus 2. This question says, use the answer sheet. Okay, I don't have the answer sheet, but we can just draw it over here to sketch the graphs on the same system of axes for 6 marks. Okay, so we obviously need a y-axis and we need an x-axis. Okay, so the first thing is, let's just write out our equations. So we've got this one equals to a is 1 and c was minus 4. And then g is 1x minus 2. Okay, so let's start with g, because g is a straight line. So how do we draw a straight line? How to draw a straight line? Well, it's easy. You need an x-intercept and you need a y-intercept. To find an x-intercept, you make y 0. So you take the equation, which is over here, and you make y 0. So you make that part 0. And then you're just going to solve for x. So you can take the 2 over to the left, so x is 2. So that is the x-intercept. It's at 2. So you can go to the 2 over here and just put the x-intercept there as 2 and 0. Then to find the y-intercept, you make x 0. And so you make x 0 in this equation. So you end up with that. And so that just becomes that, which is minus 2. So the y-intercept is at minus 2. So you just go down to minus 2 and you put your coordinates. And now we can connect them. And then we should go through, boom, and boom. And that is the equation of g. Okay, nice. Now we need to understand that this over here is remember we in grade 10 we do 4 graphs. We do straight lines, exponentials, hyperbolas, parabolas. This is a parabola. Remember, a parabola is the one that can either be sad or it can be happy. The first thing we can easily identify is this minus 4. That means that at minus 4 on the y-axis, that's where it's going to turn, okay? It's going to turn over there. So let's put that as 0 and minus 4. The next thing we need to go and do is we look at this number here. We can see that that number there is a positive, the number in front of the x squared. Because it's positive, it means that our graph is going to have a smiley face. So it's going to be smiling like that. Can you see the smiley face? If the number in front of the x squared is a negative, then it would have had a sad face. So it would have gone like down, like that. But this one's definitely a happy face graph, so it's definitely going to go something like this. But we shouldn't actually draw it just yet, because we still need to go find where it's going to cut over here. So we need to go find the x-intercepts. Okay, so to find x-intercepts, once again, to find x-intercepts, we make y 0. So we're going to take this equation and we're going to make y 0. So like that. Okay, now there's different ways of solving this. You can use difference of squares, or you can take this 4 to the left. Then you can take a square root. So you'll say plus minus. Now what is the square root of 4? It's 2. So the x-intercepts are going to be at positive and negative 2. So that's going to be here at negative 2 and here at positive 2. So it's going to go through that point over there. Oh, my graph's terrible. And then through that point over there. There, that is how you would get 6 marks. Okay, so it now says, determine the value of gx minus fx. Okay, I had to look on the memo because that question makes no sense. They made a mistake. So it's good. It's what is g of 0 minus f of 0. Let me write that over here. So g of 0, can you see that they've made x 0? So they want to know what is the y value when x is 0 on the g graph. So on the g graph, when x is 0, what is y? Well, here we can see it over here. It's this point. When x is 0, y is minus 2. So you're just going to go put minus 2 over there. And then when on the f graph, which is now the parabola, when x is 0, what is y? So when x is 0, what is y? Minus 4. So you can just go say minus 4. So now you have a minus 2 plus, because two negatives make a positive. And so the answer is 2 for that question. Sorry about that. I didn't realize that only until now. I don't go through the questions before I record. This last one over here for 2 marks says, for which values of x is g of x bigger than f of x? So where is g of x bigger than f of x? What that means in everyday language is, where is g above f? So where is the graph of g above the graph of f? So that would only be in this portion over here. Let me get a better color. It would be, can you see that in this area here? Which graph is above? You can see that the graph of g is above the graph of f, which is over here. See that? And so the answer is going to be from this point, which we actually do have. I just forgot to write it in. They said the graphs intersect at point A, so minus 1, minus 3. And we can see that's where they do intersect. So minus 1, minus 3. So the answer is going to be from there up to there. So from, and they said determine the values of x. So we could say x is, now we could say x, you wouldn't write it like this. X is from minus 1 to 2. You got to write it mathematically. So you could either use interval notation, where you would say x is an element going from minus 1 up to 2. I'm using square brackets because they are including. And then if you wanted to use like the other method, you could say x is bigger than or equal to minus 1 and smaller than or equal to 2. And let me just explain that whole above and below thing. So can you see that as we go in this area here, which graph is above here? Well, we can see this graph is higher than this graph. Can you see it? This one is higher up than this one. And as we go over here, can we see that this graph is higher than this graph? See that? The parabola is above the straight line. So the only place where the straight line is above the parabola is in this yellow region over here. You can see the straight line is higher up than the parabola. That's all that we mean when we say that. Here we have an exponential graph, and they've given us this part over here. All that they haven't given us is this part. So it says that the first question says, use the laws of indices. If you don't know what indices means, it's also exponents, to show that this is the same as this. Okay, well, we know that if you have something like 2 to the x plus 2, you can actually rewrite it as 2 to the x and 2 to the 2. And we know that 2 to the 2 is 4. And so what we can see then, if they give us 2 to the x plus 2 plus k, we can write it as 2 to the x times 2 to the 2 plus k, which is the same as 2 to the x times 4. And we can just put the 4 in the front. And so we end up with the same thing like that. Okay, next question, determine the value of k. This one's really easy. You can literally just take the equation. So the equation is f of x equals to, I don't know, you can either write it like this or you can just write it in the new way. It doesn't really matter. Let's just go write it like this. And then you can substitute a point on that graph. So any point, I can see this point over here. So the x is 0 and the y is 5. So the y is a 5, the x is a 0. And so that's going to give you, if you type this in your calculator, it's just going to give you 4. And then if you get k by itself, you're just going to get 5 minus 4, which is 1. So k is 1. Now it says write down the equation of the asymptote. This is the asymptote. So the answer is either, now you need to choose which one's correct. Is it going to be x equals 1 or y equals 1? Well, all you do is you just look at this number here. You see it's a 1. Now, what is 1 over there? Is the y value a 1 there, or is the x value a 1? If I asked you what is that coordinate, would you say 0, 1? Sorry, let's write that a bit better. 0, 1. Or would you say that it's 1, 0? Well, it's definitely got an x value of 0 and a y value of 1. So did you hear what I just said? Y value of 1. So we call this dotted line the y value of 1. So there's the answer. Y equals 1.